Hello students, welcome back to OrganiChemVerse. In the last video, we have discussed how to name the alkene molecules. In this video, we will learn how to name the alkyne molecules. Alkyne molecules are the organic compounds with the general formula CnH2n minus 2, where n is the number of carbons. For example, if there are two carbons, so the number of hydrogens would be, so 2 multiplied by 2 would be 4, 4 minus 2 is 2. So here C2H2 is the first member of the alkyne molecules. And what do we call it as? It's a ethyne molecule. As the suffix here we are going to use "-ine". And there are two carbons. Therefore, the root word is eth. Therefore, molecule is ethyne. You see, alkyne molecules have a triple bond. That means what? The carbons here are sp hybridized. Therefore, here we have a linear shaped molecule. That is very important when you write the structures of the molecule. Now, when there are three carbons, we call the molecule as propyne. And by default, this will be one propyne. Why so? Because there is only one triple bond, and always you have to choose the longest chain of carbons and make sure that the triple bond carbon will get the least possible number. It need not to be always one. Okay, so for example, in this case, you don't have to number from here. You choose the longest chain, right? Either from left to right, right to left, however, but the carbons of the triple bond should get the least possible number and take the second number. So name of the molecule is 2-butene, or you can even write it like this: but. At the second position, the triple bond is there, -2-ine. Remember, between a number and letter, there's always a hyphen like this. Now, let's take the fourth molecule. Choose the longest chain of carbons, and since the triple bond carbon can get the first number, so that is more preferable. Therefore, the name of the molecule is 1-butene or but-1-ine. These are some of the simple alkyne molecules. Now, let's name a little bit complicated alkyne molecules with substituents. For the given molecule, make sure that you will choose the longest chain of carbons, and the triple bond carbon will get the least possible number. If we number from here 1, 2, 3, if we number from here 1, 2, 3, either way, the triple bond carbons are going to get 3 and 4, 3 and 4. But if we number from this position, right, from here, then what happens? The substituent methyl will get the least possible number. The locant number is less. Therefore, we are going to number in this direction itself. Then how to name this molecule? The methyl is a prefix. Therefore, 2-methyl. And in the longest chain, there are 6 carbons. Therefore, hex. At third position, the triple bond is at 3-ine. This is the correct IUPAC name of the molecule. Now, let's see this molecule. This is interesting. Here, the molecule is somewhat in a condensed structure. So, you don't see any carbon-carbon bonds. And you see there are 3 methyl groups. So, in order to understand this better, you elaborate the molecule like this, so that you won't make any mistake while naming the molecule like this. Right? And then it will become simple for you to write the structure of the molecule. You see how many CH2 are there? 1, 2, 3. So 1, 2, 3, and then there is a CH3 like this. Okay. Now, if we number from here, 1, 2, 3, 4, 1, 2, 3, 4, 5. So it's better to number from this side. So how many carbons are there in the longest chain? There are 9. 9 means we call it as no 9, right? And then at second position, 2 methyl are there. Therefore, 2, 2. Between two numbers, always a comma. 2, 2 dimethyl non, and at fourth position, there is a triple bond 4-ine. This is the correct IUPAC name of the given molecule. For the given symmetrical molecule, however you are going to number, the carbon of the triple bond is going to get the third number. So I'm going to start numbering from here. And also observe that all these are bond line structures, and whenever you write bond line structures, make sure that the carbons attached to the triple bond are always linear. So it has to be like this. From here to here, it should be linear. Why so? Because the triple bond carbons are sp hybridized. If you're writing something like this is a very wrong representation. So never make this mistake. All right. So moving on. So once you number it, right, at second and fifth position, there are two methyl. Therefore, 2,5 dimethyl. There are 6 carbons. Therefore, hex 3 ine. That is the IUPAC name of the molecule. Now, for the next molecule, this is kind of interesting. See here, we have methyl here, right? We have a ethyl here. So choose this methyl as well as ethyl in the longest chain. What I meant is, if you start numbering from here, 1, 2, 3, 4, only 4 are there. But start numbering from here, say 1, 2, 3, 4, 5, 6 and 7, or 6 and 7. Either way it is correct. Okay. So choose the longest chain including the triple bond. And if we number from here, 1, 2, 3, 4. So 3 versus 4. 3 is better than, right? So then how do you name this? At fifth position, there is a ethyl. Second position, methyl. Alphabetical order of priority. Therefore, 5 ethyl. And second position, methyl. 2 methyl. 7 carbons are there. Therefore, hept. And then 3 ine. Or 3 heptine. Either way it is correct. This is the correct IUPAC name. Now, let's see the last molecule here. This is interesting. You start numbering from the triple bond carbon. So it's a terminal triple bond. This is non-terminal, non-terminal. This is terminal. It is at the end, right? So terminal. You either take here or here. It's not going to make any difference like this. Now, what is this group called as? Right? This group is a isopropyl. Isopropyl. And iso is a part of the name of the molecule. Therefore, I must be considered in the alphabetical priority but not P of the propyl. Now, what is the other group we have here? Methyl. I and M. So, I will get the priority. Therefore, how we are going to name this as 3 isopropyl and 4 methyl. 5 carbons are there, therefore pent. At first position itself, triple bond is there, pent, 1 ine. That is the correct IUPAC name of the molecule. Now, let's understand how to name these complex alkyne molecules. First, choose the longest chain and number it like this. So this is our longest chain of carbon. And you see here, this is a linear group, right? And then we have a substituent here. What is this substituent? Look for the number of carbons. So 1, 2, 3, 4. When we have 4 carbons, you will always call it as butyl. And then check for this carbon. This carbon is attached to 3 carbons. Don't include this, okay? Just in the group. That means what? This carbon is a tertiary carbon. Therefore, it will be tertiary butyl. Tertiary is not the part of the name, right? That's why you should always take the butyl B in the alphabetical priority. What are the other groups we have here? Methyl. Methyl and methyl. And it's a dimethyl, right? We should not take the di-D here. M of the methyl must be considered for the alphabetical priority. So which will be coming here first? The tertiary butyl. And on what position it is? Third. Therefore, 3 tertiary butyl. At what position we have methyl? 4,4 dimethyl. And how many carbons are there? 5. Therefore, pent. At first position, that means it's a terminal triple bond. 1-ine or 1-pentyne. So that is the correct UPAC name. Students, you might have observed here, we are using numbers like 3, 4, 4. If I would have number from here 1, 2, right? It would have obeyed the lowest sum rule. That means what? When you add the locant numbers, right? So 2 and 2, that would have been much lesser as compared to 4 and 4. But if we number from here, the triple bond carbon will get the fourth number, which is not correct. Here, the triple bond is the functional group. That should get the priority, but not the methyl groups. That's why this is the correct UPAC name of the molecule. So now let's see this one. This is also terminal, so better number from here, right? Either this side or this side, doesn't matter. It's a symmetrical molecule. This is the longest chain now, right? And count the number of carbons 1, 2, 3, 4. But this is a secondary. Therefore, it's a secondary butyl. And you should take the B of the secondary butyl for the alphabetical priority. At fourth position, we have methyl. So what will be the correct name of the molecule? 3 secondary butyl. Secondary butyl. At fourth position, we have methyl. And then hex 1-ine. Like this. There is one more method of naming this molecule. What is it? The secondary butyl group can also be named as, so you choose this as the longest chain of carbons, right? So this as a propyl. This propyl, in turn, it is attached to a methyl group, right? So at first position, we have a methyl group. So how do we name this? So there is a methyl here and also methyl here. But what we have to consider in the priority, so since this is directly attached, the propyl of P and methyl of M must be compared. That means what? The methyl group will get the priority. Therefore, first you have to write it as 4-methyl. And then at third position, what do we have? At third position, we have a methyl attached to the first carbon of the propyl. Therefore, 1-methyl propyl. So at third position, propyl. So 3-propyl, which is attached to 1-methyl, and rest of the name is as it is. That is nothing but hex 1-ine. So this is the correct UPAC name of this molecule. In the next video, we will see how to name the diene molecule, diene molecule, and alkyne molecules. Thank you for watching this video. Until next time.